Traffic congestion has become a serious problem for many cities around the world. According to the 2011 Urban Mobility Report, in the United States alone, almost 5 billion hours are lost to congestion each year at an annual cost of $101 billion. While population, drivers, vehicles, miles traveled, and hours of delay have all seen double-digit growth, the number of lane miles of roadway grew only 6.6% between 1982 and 2006. The new challenge for planners and highway engineers is to utilize cost-effective methods and technologies in order to meet this increasing highway demand. One approach to congestion mitigation is to build new capacity by adding new roadways or by increasing the size of existing roadways, either outward with widening, upward in elevated structures, or downward in tunnels. Building new capacity is both time-consuming and extremely expensive, up to $10 million per urban lane mile according to the FHWA. Another congestion mitigation strategy focuses on utilizing the existing roadway capacity more efficiently with little or no additional construction. Managed lanes are growing in popularity as many agencies search for alternatives to expensive new construction. Agencies that implement managed lane facilities must choose a method of separating opposing lanes of traffic. Overhead lights and plastic delineation are common in managed lanes facilities, but there are serious safety implications, and eventually this type of configuration will result in head-on collisions with serious injuries and fatalities. Buffer lanes can be used, but this defeats the purpose of using managed lanes to mitigate congestion. Movable barrier technology is used for managed lanes in construction applications to create safe, dynamic highways that offer real-time roadway reconfiguration while maintaining positive barrier protection between lanes. For managed lanes facilities, movable barrier is used in areas where there is a directional or tidal traffic flow to redistribute unused capacity from the off-peak traffic direction to give more lanes to peak traffic. The movable median is perhaps the simplest way of optimizing highway capacity. In this case, there is no fixed barrier on the highway, and the movable barrier is the only barrier. The barrier is moved back and forth multiple times per day to reconfigure the roadway based on the needs of peak traffic. In cases where a single movable median barrier may not be practical, contraflow lanes can be created using two movable walls, one on each side of the roadway. The barrier is moved out one or more lanes to give extra capacity to the peak traffic direction, and the lanes are returned during off-peak traffic periods. The critical importance of positive barrier protection between opposing traffic lanes can be seen in these case studies. In each case, plastic delineation and overhead lights were used to separate traffic as the lanes were reconfigured throughout the day. The Coronado Bridge in San Diego had 21 crossover accidents in the 3 years prior to implementing movable barrier with 2 fatalities, and the Auckland Harbor Bridge had 20 crossover accidents in the 5 years prior to movable barrier with 10 fatalities. Since implementing the positive protection of movable concrete barrier, both facilities have experienced 0 crossover accidents and related fatalities. Movable barrier provides agencies with a flexible and safe way to create unique managed lanes facilities. In San Diego, the I-15 corridor has 4 lanes in the center of the freeway with a movable median to create a 1-3, 2-2, or 3-1 configuration based on the needs of peak traffic. In Sydney, Australia, a movable median barrier adds a center lane to the peak traffic direction, and the outside lane is converted to a bus-only lane during the AM peak. Movable barrier is a 2-part system. The first part consists of 1-meter sections of highly reinforced concrete or steel barriers that are pinned together at each end to form a continuous barrier wall. The barriers have a modified T-top, which acts as a lifting surface for the transfer machine. The second part of the system is a barrier transfer machine, or BTM, which lifts the barrier and passes it through an inverted conveyor system, transferring the barrier from 8 to 24 feet in one pass at speeds up to 10 miles per hour. When necessary, the ends of the barrier are protected with the Absorb 350, a water-filled crash cushion with a T-top that is also pinned together so that it can articulate through the transfer machine for seamless operation of the entire system. Movable barrier provides environmental benefits from mitigating traffic congestion, including improved air quality, reduced traffic congestion, improved fuel efficiency, better use of land resources with a minimal environmental footprint, reduced atmospheric CO2, and increased bus rapid transit capacity and usage. The movable barrier system has other benefits that should also be considered. Movable barrier is a cost-effective strategy to add roadway capacity. The system can be operational in months compared to years for new construction. The safety of the managed lanes facility is improved with positive barrier protection. Barriers can be unpinned and opened for improved incident management. The system is a reusable asset that can be redeployed multiple times as conditions require. At about a tenth the cost of constructing urban freeway lanes, it stretches transportation dollars. Movable barrier can also be used in construction projects to provide positive barrier protection, accelerate construction work, mitigate congestion, and reduce, combine, or eliminate construction staging. Movable barrier leaves more lanes open for traffic during peak periods and creates more work zone space during the off-peak. In a construction work zone, there should be a balance between the number of lanes that are available for motorists and the space requirements of the contractor. Typically, this is addressed in one of three scenarios. First, to give the maximum number of lanes to traffic, the size of the work zone must be reduced. In this scenario, congestion is minimized, but the work zone is confined and inefficient. In the second scenario, the work zone is expanded. This allows for larger, more efficient equipment to accelerate the construction schedule, and more space means a safer work zone. The impact on traffic is increased, however, as the number of vehicle lanes is now reduced, creating congestion and potentially increasing vehicle accident rates. The third scenario is the most efficient use of the roadway. In this case, the maximum number of lanes is made available to motorists during peak traffic hours, and the road is reconfigured to increase the size of the work zone during off-peak hours. Unfortunately, implementing a flexible divider between vehicle traffic and the construction work zone is traditionally accomplished by using plastic cones, barrels, and other flexible delineators that offer no positive protection. This can lead to work zone intrusion accidents with injuries and fatalities. One solution to this problem is movable concrete barrier. Movable barrier is a crash-worthy lane separator that can be reconfigured in real time to give more lanes to peak traffic or expand the work zone during off-peak hours. Vehicle mobility is maximized without compromising the safety of positive protection. On I-5 in Devore, California, Caltrans implemented an innovative work plan that combined 24-hour shifts and extended road closures to accelerate a pavement rehabilitation project. A movable median barrier was deployed to keep 2 lanes open in the peak direction at all times. The construction schedule was accelerated from 8 months to 6 weeks. Caltrans realized a construction savings of more than $6 million, 25% of the original estimate of the total job. And movable barrier kept traffic flowing and avoided long queues during peak travel times. In Wisconsin, the western span of the St. Croix River Bridge needed redecking. It was determined that to avoid massive traffic backups, 3 lanes of the eastern span would need to be available for peak traffic at all times, but there were only 5 lanes available. A movable barrier was implemented to create a 3-2, 2-3 lane configuration based on peak traffic conditions. This allowed the western span to be closed completely for repairs instead of staging the repairs to keep traffic lanes open. The average peak period traffic speed was 51 miles per hour. It was estimated that without the movable barrier, peak speeds would have stalled at 9 miles per hour. Because of the full span closure, construction was completed in 1 season instead of 2. Construction savings from early completion were estimated at greater than $1 million. User delay savings were estimated at greater than $1.5 million. Because of the positive protection, there were no crossover accidents during construction. Barrier Systems has been helping agencies solve their traffic congestion problems in permanent and construction applications for over 25 years. With hundreds of movable barrier projects worldwide and a full line of road safety products, Barrier Systems has the experience to help design engineers find the best solutions for traffic mitigation and work zone safety and efficiency. For managed lane facilities, Movable Barrier offers the unique option of being able to reclaim underutilized capacity and provides more lanes in the peak direction with little or no cost for new construction. Using movable medians and contraflow lanes with Movable Barrier, agencies can address their congestion problems at a fraction of the cost, time, and resources required by traditional construction methods. For construction applications, Movable Barrier is used to reduce work zone congestion, accelerate the construction process, and protect the work zone by using positive barrier protection to keep more lanes open for peak traffic and open more workspace during off-peak hours. Movable Barrier creates real savings in time-related overhead, project costs, user delay costs, and the costs associated with accidents and fatalities, while reducing harmful emissions created from work zone congestion.